So, tonight's main event. Clare Sudbery is with us to tell us about how to stop testing and break your code base. So Clare is a .NET dev. She's a lead engineer at Medtech, and I really know her as a speaker and from a podcast, Making Tech Better. And with that, let me stop sharing my screen and hand over to Clare.
Fantastic, thank you. Okay, so you should be able to see the start slide. So I'm really pleased to be here to be talking about this topic. Oh, hang on, next slide, there we go. So my name is Clare Sudbery, I'm a lead engineer with Medtech, and we help our clients who are all public sector with their software delivery. And I'm going to tell you a confessional story. And it's a story that starts out happy. The protagonist, that's me, has a quest. They're excited, they're reaching their goal, but then disaster strikes. So how do they overcome adversity, and what do they learn along the way, and what can you learn? Luckily, the story has a happy ending, and as I've already said, the protagonist is me. The quest was to create a new iOS app, which was and is a game. And the disaster came because the tests were woefully inadequate, and the lessons learned were all to do with test-driven development and pairing. So without further ado, let's talk about tests, because they really do make a difference. Okay, so is anybody willing to tell me what they think test-driven development is? Does somebody want to, just so that I can check? And also, I don't know if you can raise hands in Teams. Is it possible for people to raise hands to let me know if they know what TDD is? So we've got Dave G raising his hand. Yeah. So you're happy that you know what test-driven development is? Do you want to? Andy Ian is raising his hand as well. Does anybody want to have a go at just describing what it means? Or is that too, go on, I can hear somebody's joined, I think.
Shall I pick someone?
Yeah, if you think.
Go on then, I don't mind. Go
on, go for it.
Yeah, okay, so, well, I think it's too simplistic to say that you just write the tests first, but I think that's pretty much what it is. You write your test, make sure it fails, and then write the simplest possible code that passes that test.
Fantastic, thank you. And I put that there just so I've got some idea of, you know, kind of where people are up to. I can't assume that people know what it is, but clearly you do. That's a really nice description. Write the code, and that's really important. You see it fail as well. That's also really important, because if you haven't seen it fail, you don't know whether it's your code that's making it pass. So you see it fail, and then you make it pass, and now you know that your code is doing what it's supposed to do, because your test is telling you that it's doing what it's supposed to do. And that's going to be really relevant to the story that I'm going to tell you. So the app that I was building, that I am building, is called Squarefill. And I say that I am building it because I actually started writing this app a few years ago. I can't remember exactly when, about 4 years ago maybe, which is when I first wrote this talk. And to be perfectly honest, there was the last couple of years, I haven't really done any work on it, but I did this talk again a few weeks ago at Agile on the Beach, and I got such a rush of seeing that little picture on screen and reminding myself of this game and how much I not only enjoyed playing it, but enjoyed coding it, that I actually picked it up again just a couple of weeks ago, and I have just redeployed it. I've just added a bunch of new features, and I've got people playing it and testing it as we speak, and I've started playing it again, and I really enjoy playing it. I had wanted to build an iOS app for quite a long time, just because I have an iPhone and I play a lot of games on my phone, and I thought it'd be fun to have a go at making one myself. Also, I particularly enjoy games like this that involve moving shapes around on a screen. So, you know, there's been research that says that games like Tetris actually have quite a a strong impact on the brain. There's a lot of endorphins that are created, and I particularly am susceptible to that. I just really get a kick out of moving shapes around on a screen. I find it very satisfying. So to make my own game in this genre, so to speak, was a good thing. But it does mean that for me, the game is not just to play the game. The game is also to code the game, and the game is also to keep up with my own mastery and boredom with the game, because I'm developing it myself. Obviously, initially it was quite a simplistic game, and I was able to play it quite easily, so I got bored with it quite easily, and so I instantly wanted to add new features to make it more complex, to make it more challenging. I'm my own stakeholder, I'm my own user. I want new features, I want them now, I want it to be more fun to play. And then there's two me's. There's me that's playing the game, and there's me that's making the game, and the me that's making the game has to keep up with the me that's playing the game. And that meant that it was a challenge to keep the code in a decent state. I was impatient. And also what I decided, because I was impatient, because I was in a rush all the time, also because this was something I was doing in my spare time, so, and I didn't always have a lot of spare time. I was doing it at weekends and in the evenings, and I also had young children, and I was having to fit it around the rest of my life. So typically the attention that I was giving to this game were the dregs of my attention. They were what I had left late at night, which made it even harder for me to carry on doing this in a quality way. It made it even easier for me to get lazy and tired and cut corners. And one of the main ways that I cut corners was that I decided, you know what, who needs unit tests? Like, if you've got acceptance tests, if you've got tests that describe the behavior you want to see, that describe the game from the user's point of view, then you're testing the game, right? And all areas of the code are being touched by those tests. So why would you need anything else? They're descriptive, they document how the code should work. So, hey, I'm just going to write acceptance tests. As you might imagine, that didn't necessarily end well. I was like, up yours. I don't need no tests. That's my son, by the way. This is my other son. And then, of course, it all went wrong. So what went wrong? So what I'm going to do is I'm going to describe all of the problems that I encountered as a result of having poor test coverage, and also not just having poor test coverage, but not using tests to drive the design of the code, and not writing tests before I wrote the code. What I was doing was writing code and then writing acceptance tests, and not much in between. And these are all of the issues that I saw, all of the problems that I encountered as a result of this. And what I'm going to do is I'm going to go through them one by one. So the first one that I'm going to talk about is encapsulation. So I like this description by Martin Fowler when he describes what encapsulation is. He says the essence of encapsulation is turning a design decision into a secret. And I was confused, to be honest, about my encapsulation. And when I say encapsulation, what I'm talking about is this idea that what you want is your modules of code should be arranged around system secrets. So each module hides its secret from the other modules. And then if the secret thing changes, you avoid a ripple effect. So what you're doing is you're encapsulating your code in well-defined modules. And when I say module, that's a kind of generic term. So in my case, I'm talking about classes. I know this is a .NET meetup. I actually coded this in Swift, but I originally coded it in C#. And then I ported the code into Swift because I originally used Xamarin, which is designed to work across platforms. But I found it a bit unwieldy, and I wanted to get a bit closer to the metal. So I decided, originally I thought it was going to be for Android as well as iOS, but again, I got impatient, and it was slightly quicker and easier to just do iOS development. So I moved over to Swift and to Xcode, but I was able to port my code quite easy. I wrote a script to do most of it, to change it from C# to Swift, because they're very similar languages. So there's definitely a lot of similarity there. But I'm not actually going to talk about specific language related features in this talk. So it's going to be a bit more general than that. But this idea of encapsulation, that you've got your system secrets inside of your classes, and your classes are well defined. You know what the boundaries of those classes are. You know what the boundaries of your different areas of code are. And I was struggling with this So let's talk about why that was. And basically, because I had focused purely on acceptance tests, it meant that my acceptance tests were describing my code from the very edges of my system. So my acceptance tests, because they weren't the unit tests and they weren't testing individual units of code, so they weren't testing individual classes, they were just testing the overall behavior from the user's point of view. That meant that my tests didn't give me any help in terms of encapsulating particular areas of code. And I was struggling with where the boundaries should be between my classes. And I was finding myself writing classes that were quite bloated. So I would have one class that had several responsibilities. And the acceptance, it wasn't that all of my code was in one class, but my acceptance test didn't help me with this because I wasn't writing tests around the individual classes. It meant that it was a lot easier for me to get away with allowing those classes to become quite bloated. And it also, it caused problems with debugging, but I'll come on to that later. So related to encapsulation is also the problem of the single responsibility principle. So ideally what you want is each of your classes to be well encapsulated so that the code is hidden behind a well-defined interface, but also for each of those classes to ideally have only one single responsibility. And again, because I wasn't testing at the class level, that meant that my tests weren't helping me to pay attention to those responsibilities. If my tests had been testing at the class level, then it would have been much clearer to me because I would have been able to tell by looking at my tests that each set of tests would be testing a specific area of the code and a specific responsibility. And when you work in that way, it becomes a lot easier to see the boundaries and to see when a class is becoming bloated and it's a good idea to split it apart. So again, because I was only testing at the acceptance test level, it meant that I was struggling with single responsibility. My classes were becoming bloated and there wasn't really anything enforcing me to move away from that. And again, because I was always in a hurry, it was easy to be lazy and the problem deepened. So the next thing I want to talk about is public versus private. And by the way, what I'm going to do is I'm going to describe all of these problems and then I'm going to talk about solutions. So the next thing that I struggled with was what should be public and what should be private. So what encapsulation says is that the public interface defines the behavior, and earlier on I talked about system secrets. So the code inside a class is secret, it's private to that class, and therefore it's not necessarily going to be tested. So what you test is the public interface because that's what's accessible to your tests. And the only way to test private code is to make it public. And you don't necessarily want to be making code public purely so that you can test it. So therefore you might think, and this again I was thinking, because there were a few unit tests that I was writing, but there was some code that was inside a class, so I was like, oh, it's private to that class, so I don't need to test it. I'll just test the boundaries of the class. I'll just test the methods that are publicly accessible. But again, because I wasn't writing a lot of unit tests, that was something that wasn't often coming up. It wasn't present in my mind. And I will talk later about how I could and eventually did address that. So another problem that I was dealing with was debugging. So if I found a bug, then typically the way that I would find a bug was either because one of my acceptance tests would be failing or because I was just manually testing the game. So I was playing the game, discovering that there was a bug, and then having to debug it. But because all of my tests were testing at such a high level, I might find a bug and then I'd have to work out where that bug was. So I would have to do that simply using breakpoints and by stepping into the code. Eventually, I might identify which class the bug was in. But because I didn't have tests around that class, the only way I could check whether I had fixed the bug was to write another acceptance test. And typically those acceptance tests were quite complicated because this game involves moving pieces around on a screen. So for instance, you might, the way that the game works is that it's a bit like a jigsaw puzzle. So the image on the right hand side is what the game looks like at the start of a new level. So all of those pieces are at the bottom of the screen, and what you have to do is move them into the screen so that you get a rainbow pattern that matches the pattern on the left. And the game itself, the way it works internally, is that it actually starts by putting all the pieces into the grid, and then it moves them out into the bottom and shuffles them so that the user then has to put them back up to the top again in order to complete the level. But my acceptance test is trying to express all of that in one go. So it's trying to say, we start with this and then we end up with this, and trying to describe that in a test and trying to code it is really complicated. Trying to express a particular bug, so if you move these pieces like this into this situation, then this happens, becomes very complex. And it means that if you think you fixed it, you then have to write yet another really complex test, and even the running of it is quite slow in order to find out whether your fix is working. So again, that was problematic. It made debugging slow because the granularity of those tests was so broad. Another problem that I had was refactoring. So one of the big problems that I had, and actually still have, because I still haven't managed to fix it because it was such a big problem and I had made it very difficult for myself, is that internally I have a class called square fill point, which is just an X coordinate and a Y coordinate and a bunch of helper methods. And that square fill point class gets used in two different ways. So sometimes it gets used to talk about squares, as in, if you look at this purple square here, there's a purple square, kind of bottom right, just one individual square. That is considered, in some of my coordinate systems, that's considered as one point on the grid. That represents 1 point on the grid. And so, for instance, this blue arrow, the lower blue arrow, is pointing at 0, 6 using that coordinate system where top left is 0, 0. But it can also be described as 0, 1, 9, 2 if I'm using pixels, which sometimes I have to. I have to be able to refer to pixels, because when people are moving pieces around the screen, they're moving pixel by pixel, and I need to understand where that piece is so that I can avoid collisions. And in the code, when you're reading the code, it's really hard to know whether the coordinates that are being described are the larger coordinates, where one square is considered one square, or the pixel coordinates. And it's really and obviously I need to fix that, but it's really difficult to refactor it because I don't have granular tests that are testing how that code works on a really intimate small level. So if I refactor it, I don't necessarily know whether I've broken it or not, because I don't have tests telling me this is still working, this is still behaving as it should. Another problem that I had was a lack of fast feedback. And this also impacts on the refactoring. So what I mean by that is that if I change a small piece of functionality, the only way I can get feedback on whether or not that's working as I would like it to is via one of these acceptance tests, which is actually testing several different bits of functionality all at once, or just by manually running the code, which particularly with iOS development is slow. So it has to run up a simulator. I mean, you don't have to deploy it to your phone. That would be even slower. You can run it on a simulator on your laptop, but it's not fast. So every time you want to test, particularly if I'm doing kind of tweaking fine details about how pieces move in relation to one another, I have to run up the app, and then I have to get it into a position that tests whatever it is I'm trying to do. That's slow. So if I can't quickly find out whether I'm having the impact that I want to have. And then another problem that I had was trying to reason about edge cases. So for instance, this gives you some idea of the kind of edge cases that I was having to consider. These are diagrams that I drew of shapes moving around obstacles. And there are lots of different ways in which shapes can encounter obstacles. They can approach them on a diagonal. They can move down the side of obstacles. They can move in a channel, a kind of corridor between two obstacles. They can move into a corner from the inside, or they can hit a corner from the outside. And depending, also particularly because some of these shapes are not simple shapes. So if you look at number 14 on there, that's an L shape. That shape is about to hit that obstacle, and it's going to hit it in more than one way. So there's only one bit, it might be that only one bit of that shape is going to hit that obstacle and another bit might not. Or it might be that the shape will be able to move up to a point until part of it hits an obstacle. Trying to reason about all of those different edge cases, if you don't have tests that just test one small edge case and nothing else, again, that becomes difficult. And finally, there's the question of what you do with spikes. So there's often a debate in teams about whether you want to write tests when you work on a spike. And when I say spike, what I mean is you might have an idea for something new that you want to experiment with. And quite often what you'll do is you'll call it a spike. And you'll say, this is just an experiment. This is, you might time box it. You might say, we're only going to spend a day on this. We're just going to quickly run up some test code just to kind of have a bit of a play, experiment with a new tool or a new way of doing things. And because this isn't going to be production code, this is just us playing around. Quite often people say, oh, we won't bother writing tests for it because we're just going to try it and then throw it away. But of course, what often ends up happening is it becomes production code and now it's not tested, and that can cause all sorts of problems. And in my case, the example that I had was actually I did start playing around with different ways of working with pixels and units, which is a problem that I was trying to describe earlier. And then when I did actually partially solve that, that code became production code. And again, because I'd said it was, told myself it was a spike, there weren't tests around it, and problematic. So, okay, how did I fix all of this? And how do tests help with all of this? And not just tests, actually. So this first image is of me and Sal Freudenberg, who you might have come across. She used to speak a lot at conferences. She's actually sort of retired from the industry now. But she and I started pairing together. And that was very deliberate on my part, because what I realized was part of the way that I'd been able to get away with writing substandard code with minimal tests and not writing tests for huge chunks of the code that I was writing was because nobody could see what I was doing. I was working on my own. It was my own little side project. Nobody knew. And one of the many benefits I find of pairing is that actually, if there's another pair of eyes on what you're doing, then first of all, they can stop you from disappearing down rabbit holes, because they can say, well, hang on a minute, what are you doing and why? But also the same goes for testing. They can kind of keep you can agree between yourselves what your standards are and keep each other honest. Say, oh, hang on a minute, why aren't we writing tests for this? Why aren't we using test-driven development? Because we agreed that that's what we were going to do. So I deliberately brought Sal on board to keep me honest, and that worked really well. So that was the first thing that I did. I invited Sal to join me. I like this again, this is both of my children, it's really nice little image. So big brother stabilizing little brother who's possibly about to fall over, and I think that just that image really nicely illustrates what can happen when you have a pair, is that you can keep each other stable, stop each other from falling over. So how does test-driven development help? So the first three things on my list are all helped by test-driven development. So if we start with encapsulation, I'm actually doing all of them at once. So encapsulation and the single responsibility principle and public versus private. What I started doing was saying, okay, acceptance tests are great, but let's not stop there. So let's use the outside-in method, where we start with an acceptance test, but in order to make it pass, we're going to need to implement some classes. So the very next thing we do is we say, okay, what are the tests going to be on those classes? And it might be that you've got nested classes. So you might say, okay, well, there's maybe some kind of coordinating test on the class on the outside, and now there are going to be more classes within that, and I'm going to write tests for those, and I'm going to keep defining classes and writing tests until finally I get to the smallest possible unit of code and make that test pass, and then radiate back outwards again and make all of the kind of enclosing tests pass until finally my acceptance test passes, but it's the final step. All of the other tests are also passing, and I've got tests all the way through to the most granular level. And what that helps with is, first of all, identifying how your code is going to be encapsulated, because the tests are effectively defining the classes. They're saying, this is what I think this class should do. This is what I think this class is responsible for. So it really helps you to encapsulate your code. And it also helps you to very quickly spot when one class is taking on too much responsibility. And you can say, okay, well, actually, these tests are saying that this class should do this, this, and this. So actually, how about we split this class up into separate classes that all have one responsibility each? And it becomes very clear because your tests are documenting your code, and your tests are splitting apart into one or more suites of tests per class, and you can see the tests are telling you what the class is doing, and they're very much demonstrating to you that your classes are well encapsulated and have single responsibilities. And it also helps with the public-private question, because what I find is that if I find that I've got private methods that are doing a lot, and I really want to be able to say, you know what, I want to write a test that checks what this private method is doing, but at the moment I don't want it to be a public method within my code base, then generally that's giving me a hint that actually this piece of functionality is so important that it should be pulled out into a separate class. So it should be on the public interface of a new class that is used by the original class. So there's now a communication back and forth between the original class and the new class, and the new class has these methods publicly defined. It's clearly defined what its responsibility is, and you can also clearly test it. So whenever I find myself being tempted to make private methods public, what I tend to do is say, well, actually, you know what, this is probably a new class. And using the tests to define it really helped me to make those decisions. So the next one was debugging. And I mean, again, the way that I've described the problems probably make the solutions kind of obvious. But now that I'm writing tests at a unit level, it means that when something breaks, I can actually see those tests fail at the unit level, right next to the code that's broken. And it means that I can say, okay, look, this is where the broken code is. So now when I'm debugging, rather than just knowing something within this whole giant area of code, this suite of code is broken, I can see it's something here that's broken. It's this bit here. And it's a lot, not only is it easier to find where the broken code is, it's then easier to experiment with what you need to do to fix it, which actually comes on to our fast feedback point, which is that I can say, well, okay, what about if I tweak this and then run my test instantly, and my test tells me, did I fix it or did I not? Or did I break other things? The tests can tell me, and what I don't have to do is run a whole acceptance test or even manually run up the whole code and test it manually. So yeah, I've spoken about debugging. And then the next one is refactoring. So one of the interesting things that you can come across when you're refactoring you are trying, what you're saying is, okay, so I can see I would like to change some code. I'd like to move things around, for instance. And in order to do that, I realized, for instance, maybe I'm going to take this code that was private in this method, I'm going to make it public on a new class, or maybe I'm going to move some code from one class to another. What you can do as a temporary measure is you can say, I'm going to make it public just while I'm moving things around so that I can test that everything is still working. Then I can move things around and then I'll make it private again. But the point with refactoring is that you always want to make the smallest possible change. So the best way of doing refactoring, it can be very tempting to say, I'm going to move this whole class around, I'm going to break it in two, and I'm going to take these methods and move them over there, and while I do it, everything's going to be broken. You know, the code won't even build, but that's all right because I know what I'm doing. So I'm going to pull everything apart and then put it back together again, and in the meantime everything will be broken and the code won't build. And then while you're doing that, you discover, oh, but hang on a minute, oh, this isn't actually quite going to work because I also need to move this thing over here, and now this call is broken, oh, and now there's this whole chain of calls that are all broken, and oh, I can't make it build anymore, and I'm changing everything, and if I try and do a merge at this point, it's just all going to be horrible. And so it's really important, I found, when refactoring, to resist that urge and say, I'm just going to make a tiny change. I'm just going to make this private thing public for a minute. And I'm going to check that it builds. I'm going to check the test pass. And then I'm going to add one parameter to this function. And I'm actually going to create a duplicate of this function while I do that, so that I don't break all of the clients of this function. And I'm going to make sure it builds, and I'm going to make sure my test pass. And I'm going to keep doing it in tiny, tiny steps. And all of that is great, but it doesn't work if you don't have tests in place. So particularly when you're trying to make things better, the best thing to do is to write the tests first, and that might mean that you make some things public and make, you know, maybe break some coding principles to make sure that you've got tests around everything, then fix it. And the reason for that is that it means you can make sure every single step that your tests are all still green, and you know that you haven't broken anything while you were refactoring. And what I found was that because I didn't have tests before, so back to the refactoring point, because I didn't have tests around everything, it was really, really hard to refactor. So particularly with the pixels issue, I couldn't, if I tried to fix it and it touched every area of the code, I didn't know whether I'd broken everything because I didn't have tests that were testing everything. But I couldn't make the code work better. I couldn't write the tests until the code was better, and I couldn't make the code better until I'd written the tests. And I ended up in this quite nasty kind of loop. So yeah, refactoring became very hard. And talking about fast feedback, I've kind of covered that now. But if I have tests at a very granular level, then that means that I can see instantly if the change that I've made has had the impact that I want it to have, because all I have to do is run a very small test and know instantly, rather than having to run the whole code or run a whole acceptance test. It makes things a lot faster. So yeah, another thing that I talk about when I talk about fast feedback is this idea of don't wait for the racetrack to test the car. So it can be very tempting to think, okay, I've got this small piece of functionality that I want to make sure, or small piece of logic that I want to make sure it works. And so what I'm going to do, but I can't test it until I've got the whole app running and working, and I can run it on my phone, and then I can test to see it's working, which is this idea that I'm going to make the racetrack before I test the car. But if you have small granular unit tests, you can actually test one small piece of logic even before your app is up and running. But I would add the caveat to that, which is that skeleton cars can often be driven. And what I mean by that is that I generally, so the implication of talking about don't wait for the racetrack to test the car, you might think that you're saying, okay, so, and this is something that people often do, they say, well, I've got this bit of logic, I haven't built my app yet, but I've got this little bit of logic, I'm just going to write that. I'm not going to worry about deploying my app. In fact, I'm going to leave that way down the road because that's going to be difficult and time consuming. So I'm just going to write all these different bits of code, and I'm not going to make the thing deployable until quite late on. And the problem with that is that then you discover a whole load of problems with deployment and integration that you hadn't thought of. So I wouldn't recommend that. I would recommend that you start with a skeleton that is deployable. So just your hello world, you know, something that just literally hello world, but it's deployable. You can get it on your phone in this instance. Obviously, not all apps are mobile apps. And you can see it deployed and in the world. And I would prioritize that. Generally, but still the point of don't wait for the racetrack is don't feel like you have to run up a whole app in order to test one small feature. That's the point that I'm trying to make there. So the edge cases, I mean, again, it's kind of obvious, but the way that I fixed this was by writing individual unit tests for individual edge cases. And the great thing about that is not just that each edge case is easily testable, but also just in the process of writing those tests, it tends to really focus you on thinking about what are those edge cases. Because as soon as you start thinking about 2 or 3 of them, then it kind of spurs your imagination to think about all of the other possibilities. And also drawing diagrams is really, really useful. In this case, it is a visual thing that I'm building, so it's quite obviously diagrammatic. But even when it isn't obviously diagrammatic, diagrams are such a useful tool, and they're often underused. If you can draw a diagram of something, it's such a good tool for communication, even if you're only communicating with yourself, because it can record how you think about something, and it can also help you to think about it in different ways. So drawing diagrams and writing unit tests for each individual edge case was something that I found really helpful. And then the last one is the spikes, which again, I've kind of covered. But if you're going to do a spike, even if you think it's going to be thrown away, still write tests. And it's not only because they might end up in production. Actually, writing the tests helps you to define what this problem is that you're trying to solve. What is this experiment trying to prove? What's your hypothesis? And your tests can really help you to say, okay, this is the thing that I'm trying to prove. This is how I'm going to prove it. Now I'm going to create this spike and see, can I make these tests pass? Is it doing the thing that I want it to do? The exception might be when you're experimenting with brand new tools and you don't even know how to test them yet. And actually one of the things the spike is for is to help you to learn how to test. But still, by writing tests as you go along, then you are making sure that you are learning how to test the thing that you're learning, as well as how to do the thing that you're learning. So final conclusions. The story started with me facing a bunch of obstacles. This is my son Oscar again, with things getting in the way. There was a lot getting in my way, but I ended up happy. And it was the tests that freed me. It was the tests that allowed me to really start flying and making progress. So not having tests, it can feel like you're moving faster at first, but then you grind to a halt. It is a false economy. And it's not just that not having tests is a false economy, it's also that not running tests is a false economy. So it can also be very tempting, particularly if any of your tests are slow, to think, well, you know what, I'm just writing this little feature here, this little bit of code. So I'm only going to run the test that tests this bit of code. I'm not going to run my full suite of tests whenever I make a change. And then it's not unusual, and it's definitely happened to me a few times, that I think I've only changed one thing, and then I run the whole suite of tests, and it turns out that about 5 commits ago, I broke a related piece of code. And now, because I didn't run the tests every single time I committed, I'm not sure which of those commits. It might have been 20 commits ago. I don't know which one of those commits was the one that broke this other bit of code. But if I run the tests every single time I push the code and every single time I commit, then I'm not just testing the little bit of code that I've written. I'm also testing what impact it has on the rest of the code base. The other learning is that tests facilitate refactors. It's a lot easier to refactor if your code is well covered by tests, because it means that you can very quickly see if your refactor is breaking your code. And what goes hand in hand with that is making sure that when you are refactoring, you only ever make very small changes. And every time you finish a change, you build the code, you run it, and you run the tests. And that you have those tests in place before you start refactoring. And then the other really big lesson that I learned is acceptance tests are not enough on their own. They're great, but they're not enough on their own. And another thing that I learned, because I did have this kind of intermediary phase of where I didn't have good test coverage, but I was still discovering bugs. And so what I did was every time I found a bug, I wrote a test to cover that bug. So as soon as I found a bug, before I fixed it, I wrote a test that said, this should work in this way, but it isn't. So I could see that test failing. And then that meant that once I'd fixed the bug, the test would pass and I could tell that I'd fixed the bug. But also it meant that there was this kind of ongoing documentation and protection, so that if I accidentally reintroduced that bug, I would know instantly, because that test would start failing again. And keep everything green all the time. So the other thing, it can be tempting to run your tests and know that some of them are red and think, oh, it's okay, yeah, I know that thing's broken, it's fine, I'm going to get to that, but I'm more interested in this other thing at the moment, so I'm just going to let those tests stay red for a bit. The problem with that is they can build up and you can put it off and you can end up in a worse and worse state. But another problem is that if you continue working without having got back to a green state, without having fixed those tests, then you might introduce new problems that are also covered by the same tests failing, but you now don't know whether those tests are failing because of the problem that you never got round to fixing or because of new problems. And you don't know which bits of the code are causing which problems. So always fix broken tests as soon as they're red, keep them green, so that then you can see when things are failing, you know what's caused those failures and you know when those failures happened. And then the last one is that pairing is a really good way of keeping your standards high, keeping you honest, and helping you to adhere to the standards that you would like to adhere to. And I've put that 3 more slides in brackets to remind myself. These are actually the same slides that I used at Agile on the Beach a few weeks ago. Oh, the first one is just, I wanted to show that slide again because I really like it. The next one is my podcast, which has actually already been mentioned, but I do host a podcast called Making Tech Better. You can get to it via that URL. There's also a link to it in the description for this talk. We've been running since April now. We've interviewed a bunch of great people. So I interviewed John Skeet. That was a highlight. I've interviewed Jeepor Hill. Daniel Terhorst North is coming up next week. Emily Bacher. I know Corrie. Jessica Kerr, a bunch of really interesting people talking about a bunch of really interesting topics. And also we're recruiting. So if you go to medtech.com/careers, we are always interested in finding good software developers. And that really is the end. And are there any questions?
That was awesome. Thank you very much.
Thank you.
Yeah,
So, anybody got any questions, or are we all happy?
I find, yeah, I think what you're saying about the keeping honest with pairing, I think that's a really good point, because I think the discipline aspect for me is the thing. I kind of know the theory, and I've watched videos on it and stuff like that, and occasionally I do the test first, and I think my problem is, you do just naturally just dive into the code and start doing stuff, and getting that discipline and sticking to it, I think, is the key.
Yeah, absolutely. And this is me being honest, because like it's very easy to think that all people who rave about test-driven development are all like really, really disciplined. But I totally get, particularly when you're working on something on your own and you're in a hurry, that feeling of impatience, that, oh, just this once, I just want to see it work. But then you just can get further and further down that road, and it just gets harder and harder to actually do useful things with your code base. And if you've got that good test coverage, it just makes everything so much easier.
I think starting from a good place as well. If you've got something that's not very testable, you're going to struggle to write tests first sometime, and sometimes you're going to tinker with things and so on. And I think that sometimes influences people to kind of as a default just write the code first, and that's something we need to tackle as well. Often we need to do a lot of refactoring to make something testable, so that we can then get into that discipline, I think.
And writing test code that is testable it's not only going to be testable, it's probably going to be much better factored. It's probably going to be much better encapsulated. It's going to be split out into good individual modules. The business of writing test tends to make you write code that is much more easily isolatable because you're making it testable.
Yeah, I like what you said about sort of violating encapsulation principles before you violate testing principles.
Yes, yeah, and then you get it back on track again. But the important thing is to make it testable, and it's okay to break a few principles while you're in the midst of that journey.
Yeah. Do you have any thoughts about how to make test failures obvious, or make improving the messages that you have when you're creating a test, so that when the test fails, it leads you more towards what the actual issue is?
Yeah, so for instance, I try to avoid tests that test booleans. So you might have a test that says expected true but got false, and you're like, oh, okay, what does that mean? So I would rather say expected 3 but got 4, but ideally what I will do is I will actually add messages. So most testing frameworks allow you to add an error message within the test. So you might assert that A should be equal to B, but you also add an error message saying expected length to be 4, but actually it was 5. And then oh, it was the length, or expected the length of something or other to be 4. And actually it was 5, and now it's not just that something was supposed to be 4 when it should have been 5, it was the length of this thing. And that gives you a much better idea of what it is that's broken. So I do try to either make the values that are being compared really obvious, or if that's not the case, then give it a context. So give it an error message that will appear, or sometimes you could, depending on your test framework, sometimes just the name of the test is enough, because it will show the name of the test when it fails, and the test will be well described, so you'll be able to tell because of the name of the test and the values that aren't right that, okay, yes, that must be the thing that's broken there. So I do put quite a lot of thought into that, actually. Yes, making sure that when I see my test failures that they are descriptive.
Yeah, thank you. Any other questions? Anybody got any observations? Everybody's being very shy tonight.
Yeah, I'm being very shy. Yeah, just to reinforce what you were saying, I give my tests massive long names, and I usually start them something like, given a condition, when I do something, then I expect this. And so if I've got a red or a green light, I just know instantly what's failed. So that's what I tend to do. But
yeah, I do that. I have ridiculously long test names because I'm describing the behavior. I'm describing, this is what I expect to happen in this circumstance. So yeah, I don't have a problem with that at all. I generally complain because people's test names are too short rather than too long.
I've started using like the builder pattern, or Fluent Builder. I'm trying to keep me tests like really small, using the arrange act assert structure to make it quite obvious what the test's doing, and then making sure it only tests one thing. And I don't know what anyone else thinks of my code, but to me anyway, when I look back at it, it certainly looks like it. I can see what the purpose is of the test.
Yeah, I do the same. So I generally, I'm not a fan of comments. I would rather use well-named functions and variables and class names rather than comments, as I want my code to be self-describing, because comments can become out of date without anybody knowing, because they're not compilable code. But the other thing is that the reason I mentioned that is because the only place where I do use comments generally is that I do put a comment for arrange, act, and assert within my tests. So I always split them up into 3 parts. And I find that really helpful, partly because if I'm looking back at a test, I can go straight to the bit that matters. I can see what is the code that is being tested, and that's in my ACT section. But it also gives me a feel for if there's a bit of a smell is if the arrange section is gigantic. It's making me think, okay, there's too much, there are too many dependencies here, typically, is what that's showing me. But also my ACT section should ideally just be one line of code. This is the thing that I'm testing. I'm just running this one line of code. I'm just calling this one function. And I want my assert section to be short as well. Some people say you should only ever have one assert per test. I don't agree with that. I understand why people do, and I'm like, you know, if that's how I get it, and I wouldn't say you shouldn't do that. But the reason I allow myself more than one assert per test is quite often because I'm saying I expect these things to be true once this thing has happened, and there might be more than one thing in this scenario that I think should be true and that allow me to demonstrate that this is behaving as it should. And if I split those out into separate tests, one test per assert, it means that the test suite tends to get really quite bloated and hard to read. And I want my tests to document my code. It does sometimes mean that it will obviously fall at the first assert. So if one of those asserts fails, the other asserts won't even be reached. But what I think is that, well, okay, if even one of those asserts has failed, then this is something I need to fix. So I fix that assert and then see, is the next one going to fail? So personally, I find that it just groups things a bit better. But I know some people prefer, I certainly don't want lots of asserts. You know, I want them to be kept to as smaller list as possible.
Yeah, I don't mind multiple asserts at all, and I frequently have many. But to make the code and the test readable, people might want to investigate. There's an extension, a Fluent extension method called should or shouldly, which is just you can install a NuGet package, and so you don't have to do asserts anymore. You just create the variable, do your action, and then you use an extension method, so it's should be true or should equal 4 for your lengths and things like that. And it just makes the code really nice and readable, and it puts the asserts in there automatically for you.
Yeah, that is a nice one. And another one that I haven't found an equivalent for Swift actually, but that I do use in C# a lot is Encrunch. There are equivalents. I mean, I'm kind of a bit of a dinosaur maybe because that was been around for a while now, and I just liked it when it first came out, and I still use it. But something like Encrunch that will allow you to run the test continually in the background. So Encrunch will just, I don't even have to run the tests. It detects that I've changed the code and it runs the tests for me. So I can see instantly that it'll go red if I've broken something, and I'm not even explicitly running the tests. They're being run for me in the background. And that's great because it means all of the tests are being run in the background all the time. So I don't have to remember to run the full suite of tests every time I do a commit because they're just running anyway.
Oh, that's been fantastic. Thank you.
It's a
Thanks so
pleasure.
much, Claire.
Yes,
have a great evening, and thank you for inviting me.
all right. Thanks everybody for attending. Next month, we've got a talk scheduled middle of the month, and I'll publish details of that as soon as I've got confirmation from the speaker. I'll let you know in the next few weeks or so. All right. Thanks very much, Claire. And thanks everyone for attending, and we'll see you next week, next month.
Okay, thank you.
Right.
Bye-bye.
Bye.
Thank you. Bye-bye.